Howdy everyone, welcome back to class. This session we're going to talk about drive axles and differentials. Let's get started with front wheel drive axles. So front wheel drive axles are generally going to be different than your rear wheel drive axles sometimes depending on the design. I will just go ahead and say not just front wheel drive axles used on vehicles with independent suspension from right to left rather than a solid rear axle or a solid front axle. So anything with independent suspension, it means I've got left and right tires and wheels that are able to move separately of each other and not affect the other side. If I had a solid rear axle, when I move one side, the other side's going to be affected, right? So a front wheel drive axle is going to look something like this, where we've got a rubber boot, and you can see that this joint is able to move. I've got a shaft here, and on the inside, this is actually going to be one of the joints I'll talk about here. We're going to be connected to our transaxle or our differential, depending on the design. And on this side, we are going to have a connection. You can see this is splined. This is going to be splined to our hub assembly out to our wheels and brakes. The job of any of these type of axles, these are actually going to be called CV axles, also known as half shafts or axle shafts. The job of any of these is going to be transferring from a final drive out to the wheels. That's it. So whether that be the final drive on a transaxle out to the wheels or the rear differential to the wheels, let's say on a rear wheel drive vehicle like a BMW, not a truck, that's sort of going to be a little bit different, and I'll explain why in a little while. So these types of axles, like I said, are called CV axles, and they're going to be capable of operating at really high angles. So we've got an inboard joint. The inboard joint is going to connect to our final drive assembly. The outboard joint is going to connect to our wheel assembly and our brake assembly. And then in the center here, we've got the actual drive axle shaft. Now with that being said, let's talk about the different joints involved. So the outboard joint, the part that's connected to our hub assembly, that's splined to our hub assembly, this is going to be called what we call a fixed or Rzeppa. It's a weird name there, R-Z-E-P-P-A, Rzeppa joint. And in a nutshell, that Rzeppa joint is going to have an outer race, an inner race, and in between the outer and inner race, we got a little cage that has some ball bearings inside. We might even be able to sort of pull this back here a little bit, and you might be able to see some of that, maybe through all the grease. And inside of that Rzeppa joint, or through that Rzeppa joint, we're able to achieve some really high angles, all the way up to 40 degrees, which for axles is really, really high. And that's because if this is my axle, right, this axle here, this is my inboard joint, this is my outboard, when my wheel moves up and down, my axle needs to be able to sort of flex and still transfer movement through that. So we need a joint that's going to be capable of operating at angles without binding up. And that's what our outboard joint does. The inboard joint needs to have an extra job. It doesn't need to operate near at the angle that the Rzeppa or outboard does, but it's still going to be operating at a height of 20 degrees or so. So if we're looking at my axle here, this is my outboard, this is my inboard. When my axle moves, the important thing is that when my wheel moves up and down, my axle needs to be able to actually change length as it goes through its arc of movement. So not only does my inboard joint need to be able to move as well as my outboard joint, it also needs to be able to plunge in and out. So this is going to be called a plunge joint, also known as a tripod type joint. So this one's already taken apart, and you can see why they call it a tripod joint, because we've got these three areas here. And if we were to sort of have a blueprint of it, we can see this here. Here's our tripod assembly that I just showed you guys. And we're going to have a sort of race, an outer race as well with the, and I don't have it here, but this is going to be the part that this is missing. And it's going to be splined into your final drive assembly as well. So like I said, the main benefit of this one is it allows the axle length to change as well as operate at up to 20-degree angles. Now, when we're talking about these are CV axles or axles. What about on rear-wheel drive vehicles when we're transferring power from my transmission to the back of the vehicle to my differential? Now we're looking at something like a drive shaft. The drive shaft itself, like I said, we've got our engine mounted longitudinally from front to back. On the back of our engine is our transmission, and from our transmission, we need to transfer power to the rear differential. So we need a long shaft that's going to transfer that power. Your drive shaft can also be known as a propeller shaft. Like I said, is transferring power from the transmission to the differential. And if it's a really long vehicle, I might have multiple drive shafts. So I'm going to call this a drive shaft. It's actually an axle, a rear axle that came off of probably an older vehicle that had independent suspension. And this is before CV axles sort of became a thing. But this is actually built very much almost identical to your drive axle. So on one side of my drive shaft, I'm going to have a shaft that is internally splined and is going to go into my transmission and spline directly to my output shaft of my transmission. That is going to spin my drive shaft. Now my drive shaft is going to have joints up in the front and in the rear. And this is going to transfer power through my drive shaft to the back. And in the back here, I'm going to hook up or mount to my differential. And in this case, well, like I said, we'll just pretend this is a drive shaft that's, say, like on a truck. This is going to hook up to the pinion gear of my differential. So as my transmission is spinning, we are spinning the entire drive shaft, and here's my final drive assembly back here that we're going to propel. Now, our drive shaft is going to have two universal joints, one in the front, one in the back. And a universal joint, if you've ever used a wobbly socket, it's very much similar. They don't operate at near the angle that your CV axles do. We're talking much, much less, like 5 degrees, right? But we do need to be able to have a little bit of an angle. So if you look at this here, I've got a little shaft through here and a little shaft through here. So you can see I'm able to have a little bit of movement. Now, if I have too much and I'm sort of cocked like that, we'll have what we call binding. So this universal joint, also known as a U-joint, is not going to be able to operate at extreme angles. But like I said, it can operate at slight angles like 5 degrees and such. If we look at the back side, it's, and this one's actually not going to have it because it's not an actual drive shaft. But I would have one on the back side where my final drive assembly or a differential assembly hooks up to my drive shaft. So that's universal joints in a nutshell. You can sort of see here, we've got a cross piece that has trunnions on each of the corners here. We're going to have little needle bearings and a bearing cup. Like I said, here's a much better picture of what it actually looks like. Now I've got something that says phasing is critical. What does that mean? So here is a little bit of an idea of what phasing is. So our U-joints, I mentioned, work at about 5 degrees. So if my front U-joint is operating at a negative 5 degrees as it's pointing down, my bottom U-joint, where it's hooking up to my differential, needs to be operating at the same but opposite angle. So we'll put it at a positive 5 degree angle. If I don't have phasing of my two U-joint angles, you're going to get vibration. So it's imperative that you get the correct length axle. And let's say you're doing something that is super custom. Let's say you're putting an aftermarket, or let's say we're putting another engine that doesn't belong in a car into, let's say I'm taking an LS and I'm putting it in a 240 or a Mazda Miata. I'm going to need a custom drive shaft, right? I can't use a stock drive shaft in that vehicle. So I'm going to use a custom drive shaft to transfer power from my transmission to my rear differential. Well, that is where the angle of my transmission and the angle of my differential is going to come into play, because again, I need to make sure the phasing of my front and rear U-joints are going to face together so I don't get this insane amount of vibration. With that being said, drive shafts also need to be balanced. So you may see drive shafts that have little weights that are sort of welded onto them. If you don't have them balanced properly, then you're going to get some vibration as well, or if the weight comes off. Or if there's damage to the drive shaft. If you have a vehicle that is on adjustable suspension, let's say air ride or hydraulics, that drive shaft can only be phased correctly at one ride height. When you lower or lift the vehicle, the phasing changes and you may actually get vibration at low speeds or at high speeds, depending on how badly your drive shaft is out of phase. So that's just something sort of to keep in mind when you're airbagging vehicles or putting them on hydraulics. Now, some axles are going to have what we call double cardan joints, and here would be an example of that. It's essentially kind of like a double U-joint. So I've got one on this side and another on this side. And that, like I said, that would just simply be an example of pretty much like a double U-joint, but they call them double cardan joints. If I have an angle that's going to be really steep, in order to maintain phasing, I can just put another U-joint, a double cardan joint on there to help compensate for that. You see these a lot on four-wheel drive trucks because they're capable of operating at a little bit more of extreme angles than your regular U-joints. Then they can be considered CV joints. Now, your differential itself is going to be that final drive before we send power out to the drive wheels. It's also responsible for sending power out to both drive wheels. Now, your differential not only does that, it's also capable and allows both sides to spin at different speeds. So if I'm taking my vehicle and I'm making a turn, my inner wheel spins at a slower speed, or needs to spin at a slower speed than my outer wheel, because it's traveling a shorter distance. Think about all the way back to high school, well, I won't say track, high school PE, when you had to run the mile, right? If you're running on the track, if you were smart, you would run on the inside of the track rather than the outside of the track, right? Because the inside of the track, you're going to make it around a little bit faster. It's a shorter distance than the outside of the track. So our differential, again, is allowing our left wheel and our right wheel to be able to spin at different speeds if need be. Now, a regular old-fashioned differential is what we call an open diff, or an open differential. This means that power is not always going to be distributed easily, or I'm sorry, power is not going to always be distributed evenly from my left to right wheel. It's actually going to end up going to the wheel that is more easily to spin, which is what we want in a turn. However, when you go to, let's say, do a burnout, this becomes a problem, and the vehicle will start to peg leg or will do a one-wheel burnout while the other is really doing nothing. And you're doing a burnout to try to impress your friends. Everybody starts laughing because you only left one burnout mark when you took off. Now, with that, you're thinking, okay, well, how do I fix the problem? That's what an LSD, or limited slip differential, is for, and I'll get into that in a moment. So when you're looking in the back of the vehicle, you can see this. Differentials, like I said, in front-wheel drive vehicles are actually located within the transaxle. Differentials on a rear-wheel drive vehicle in general, right, are going to be located in the rear. This is a picture of a solid rear axle. So our differentials right here, here's our drive shaft, here's our U-joint, here's our differential, here's our solid rear axle. So in this rear axle, I've got one solid shaft going through that side, one shaft going through that side to transfer power to each of the wheels. Here's an inside picture of your differential. So again, here's our U-joint, our drive shaft would be here. Here is our pinion gear. So our differential has a bunch of stuff in there. The two main gears are going to be our pinion gear, which my drive shaft is spinning, and that pinion gear is going to drive a big old ring gear, which is going to then turn our side gears and then turn our side axles. Again, here's sort of another picture. Here's our ring gear. Here's our carrier and our side gears, which is going to transfer power to the outside wheels. Now, the differential is going to be composed of, like I said, a bunch of components. So we've got a ring gear, a pinion gear, we've got a carrier, some bearings. So coming out each side, support bearings that are going to be there. We've got some differential pinion gears inside, some side gears. The pinion drives the ring gear, as I just sort of showed there. Now, there's two different types of pinion and ring gear drive sets. And they are spiral bevel and hypoid. So spiral bevel is going to be where the pinion is exactly in the center line of our ring gear. The problem with a spiral bevel is that my drive shaft has to be higher up, which can take up space in our passenger compartment, and it's not always going to be able to do that. So there is something called a hypoid gear set that is able to sit a little bit lower below the center line. And there's pros and cons to both, but it does determine where your drive shaft is going to sit. And then there's going to be something called either hunting gear sets or non-hunting gear sets. A hunting gear set for our pinion and ring gear mean that all of the teeth on my pinion gear come in contact with all of the teeth on my ring gear. So when I take them apart, it's not that big of a deal on how I put them back together. They're not really timed. With a non-hunting gear set, only certain teeth are going to be married to certain teeth on my ring gear, meaning I need to mark where my gears go together, because I can't just turn the gear separately and put it back together, because on a non-hunting gear set, the gears actually create a wear pattern on each other, and if you mess that up, you're going to end up eating up the gears. So that's sort of an important thing to know if you're just starting to take things apart in your differential. And then what I was getting to in a couple slides ago was our limited slip differential. So let's say you want to be able to, you want to do burnouts with two wheels. You don't want to get stuck when you're off-roading, right? Because if you're in a bunch of mud and one wheel can spin really easily, easier than the other, it's going to transfer power just to the one wheel. This wheel gets stuck, the other wheel can't do anything, and now you're stuck and need to be pulled out. So for off-roading purposes, you need power to go to both wheels as well. Or let's say you want to drift. It's going to be really hard to drift with an open differential. And so that's why a lot of people will weld their differentials. I don't recommend that, because a limited slip or an LSD is going to allow you the best of both worlds. When you're at lower speeds, lower torque, it's going to keep an open differential. So my left and right wheels can spin at the speeds they need to when you're in a turn. When you are trying to actually apply torque to those rear wheels, that limited slip is going to lock up, and we are going to have power distributed to both right and left wheels. So you can do a sweet burnout in front of your friends and leave 2 marks instead of 1. You're not going to get stuck near as often when you're off-roading because of that, and you are going to be able to drift as well, to the best of your ability. Limited slip differentials are super awesome. That's why they're normally more expensive on vehicles with the option of an LSD. Not all vehicles that are rear wheel drive have an LSD, so that's something you might want to pay attention to when you go to buy a vehicle. But LSDs are really nice. There's a bunch of different designs. So we got a clutch type, a cone type, a spool type. There's all different types of differentials. I'll try to include some videos in this week's Canvas for some better visuals on different types of LSDs. That's differentials and drive axles in a nutshell. So I will go ahead and see you guys in this week's Zoom. Please make sure you come in with your questions. If you'd like to, you can go ahead and post questions in the comments or in my inbox. So I will see you guys on the flip side.